to start. It looks like we have a great group here. We are so excited to have Kelly Yates. She is the Collaboration and Program Development Manager at the Utah STEM Action Center, and she's here to give us a little more information about what she does.
I am so excited to see so many people here. I want to tell you just a little bit about the STEM Action Center in case you don't know who we are or what we do. So we are a government office. If you think about government structure, so think of the governor at the top, and he has an office that supports him. And then there is his cabinet, and on his cabinet are the heads of multiple departments. And one of those departments is called Community and Cultural Engagement, CCE. It used to be called the Department of Heritage and Arts. It's been renamed CCE. And within that, there are 7 divisions or agencies, and one of them is the STEM Action Center. Now, what we do at the STEM Action Center is we want to make sure that citizens of Utah have access to the materials and equipment and resources they need to engage in STEM, which is really important to the state in a lot of ways, including the economy, but it's also, shown to be effective for anyone in any sort of career path. Having STEM background knowledge is advantageous regardless of what somebody decides to go into. So it's been decided that STEM is important to the state, and we are excited to help schools and educators and families incorporate STEM. So I am going to just kind of delve in and talk to you a little bit about what STEM is, what it looks like, important components. We're going to talk about some of the ways that you already do STEM. Sometimes when we start talking about STEM, people are like, this isn't for me. This is not my background. I can't do this. But the truth is, you're already doing it. So let's just identify it and maybe find ways to amp it up that you're comfortable with. And then I also want to show you some of the resources that we have available to you, and just have some conversations about STEM today and what it can look like for our earliest learners. So I'm going to go ahead and share my screen, and just so you can see my slideshow. Don't hesitate to use the chat. I also have no problem with you unmuting and just asking me questions. So don't be shy. This is for you. Make sure you get out of it what you want. So if I'm not going the direction you wanted me to cover, or you have questions about, I have no problem diverting. So let's make sure this meets your needs. All right, here we go. Yes. I'm just going to show you really quickly. This is, let's see, you're seeing it now, right? It's so weird when they're not on the same screen. You would think after 2 years. So this is my name, Kelly Yates, and my email address, kellyyates@utah.gov. I know this isn't in presenter view yet, but that's because I'm going to switch out of presenter view really quickly for our next slide. So for our next slide, I want to just start with, where are we all starting from when it comes to a conversation about STEM? So what is STEM? And I really want us to get beyond the acronym. So, when we're talking about STEM, S means science, T is technology, E is engineering, and M is mathematics. That's fantastic. What does that mean to you in your classroom with your little learners? And I've got a Jamboard that I'm going to share in the chat. So I'm going to stop. No, I'm not going to stop sharing. Maybe I will. Hold on. Well, I just learned that I can't chat and share screen at the same time. So let's go ahead, and I'm just going to pop this in here. If you will, visit that link. And if you haven't used Jamboard yet, I will show you that as soon as everyone gets a chance to copy that. So when you get there, you're going to see something that looks like this. All right. Oh, there we are, our little anonymous creatures. Over on the left-hand side, you have kind of this list of tools. And if you just go to this one that looks kind of like a sticky note, if you click on this, you can just type in your idea. So I'm going to push science. I'm going to type in science. So you see how this works, even though I don't want you to write science. I'm going to delete it. So, and then I can just keep adding ideas. When you're done, feel free to push cancel. You can change your color. And then these little friends can also be dragged wherever. So go ahead, pop up your ideas. Let's see where we're all at, and then we'll go from there. Nice. Very nice. I think I'm going to give you about 30 more seconds. Ooh, cause and effect. These are looking really good. It looks like you guys have already some excellent STEM understanding. Yeah. Now we've got our hands-on activities. Beautiful. All right. If you're still typing, go ahead and finish up. We'll just take a moment to take a look at these. So I'm going to just scoot some of these down since they all drop on that same place. Excellent. This is wonderful. I love this. We have a mix of content components. So the actual like subject areas that are being covered. And we also have a lot of the cultural components. So when I talk about STEM, I'm going to stop sharing for a minute. When I talk about STEM, I like to remember that while the content is important, like I absolutely, as a person, believe that science is important, math is important. My background is in technology and engineering, so I love those for a lot of reasons. But the truth is, the transferability comes into play when we talk about these cultural components. And those are the things like this idea here, thinking things through. That's a cultural component. Every human benefits from learning how to think things through. It doesn't matter if they decide to be a scientist or an engineer or an architect or anything like that. You know, exploration, these are all cultural components. We really need both of them to have a handle on STEM and to also be introducing our students appropriately to STEM ideas. So that being said, I'm so glad. This is wonderful. We are going to delve into some examples and conversations and some examples. I already said examples. I'm excited about the examples, apparently, of STEM activities for our earliest learners. Now, when I think at the STEM Action Center, when we design activities and items for our early learners, just so you're aware, we do use the early learning standards. We love them. And we kind of bundle ages 2 to 4. Sometimes we get those like early preschool people asking us for input. So we still use the 3 and 4-year-old standards for that, to design for that. But you'll see on some of our materials that it says ages 2 to 4, and I just wanted to address that up front. That's why. So I'm going to hop back to my presentation here and share my screen. And it's that one. All right. I wanted to just kind of reiterate, the STEM Action Center partners with the State Board of Education quite often. And one of the things that we have been working on with them, it took us over a year, but we wrote a white paper as a STEM Action Center and then the STEM team at USBE. And we identified, based on research, 3 principles that are inherent in STEM. And the image that we chose to use for this are these 3 links, because they can't really be separated. So these 3 components interweave with each other. So the first one are the STEM content knowledge. So like, you know, the periodic table, like, do you know your math facts, things like that. That is a principle, and it's important to have really effective content area instruction. It's also an important component of STEM to have some integrated content knowledge. And that's where we get that transferability. That's how we help our students practice that. And then last are these community connections. And this is where we get into things like, what career would this do? Or what career would do this? Good night, I'm struggling with my words. You know, who uses this in their work? That sort of conversation. So that being said, let's just keep going here. This is one of my favorite quotes in the whole world. It's by Leonardo da Vinci. And I think it sums up what I love about STEM. And it says, learn how to see, realize that everything connects to everything else. You know, I just think it's a lovely idea. And it's important to also remind our students that when we learn something in one area, we can learn it affects how we behave in another. So those connections are really important. And it's not just about content, it's also about people. When we get to know one person, we get better at making friends with someone else. So again, that transferability is really important. Now, we are going to delve into some science skills. And I used the early learning standards to pick apart and identify the actual verbs that are covered in those standards. And my thought was we could go through the different content areas within science and focus on how we are using these 4 skills with our young learners. So we're going to try this together. The first thing that I want you to do is look at this picture. And I just want you to take a moment, maybe on a sticky note or a piece of scrap paper, or maybe just in the chat. Can you start? What kind of things do you notice? What do you observe? What kind of data could we collect in this environment? What kind of questions do you have? What do you think? And I know it's a little blurry. So it is a picture of homes in Utah during a rainstorm. So let's take some time, write your notes out. Let me know what you come up with. Nice, good. I'm gonna give you just maybe 10 more seconds. All right. So we had some few, again, I apologize for my poor syntax today. We had some answers shared in the chat. Um, feel free to put in some more as we discuss. Some of the things that came up are habitat and weather, and that's actually the science content we would be covering with this kind of example. Serious amounts of water. Yes, I did look for a picture that showed heavy rainfall, so it'd be obvious. Green, that's a good observation. The amount of rainfall in a time period, excellent. So how could you use something like this with your students? What could we do with this? And to add to that, I'm going to show you another picture. Maybe. There we go. Nope, there it goes. What about this one? What changes in this picture? What do you think? What comes to mind when you see something that looks like this? Cold, yeah, exactly. Fun, cold, love it. Ooh, that's a good question. How do they stay warm? Different types of water, nice. Good. So how could we use this type of activity? Going back to our science actions, obtain and communicate information. How do you already talk about the weather with your students? What does that look like for you? You can unmute if you want. You don't have to type it all in there. Does anyone have their students? Oh, nice question of the day. I like that. Do you ever have your students keep track of the weather at perhaps during a week? You know, do you know, was it sunny today? Oh, beautiful, Natalie. We have a rotation where students go outside and draw what they see. Excellent. Yes. Calendar time. Beautiful. I mean, could we ask them to predict and then compare their prediction to what actually occurred? Good. Excellent. You have a weather board. Beautiful. Beautiful. Now, how could we collect what they generate? You dress a person? Oh my goodness, that sounds adorable. I think I might love that day. That's so cute. Let's talk about that, because that comes down to the next set of verbs, right? Observe and describe patterns. Well, those patterns would indicate, hopefully, how we would dress. How do you help students turn data into pattern recognition? Tell me about that process. The reason I'm asking is because I met with some kindergarten teachers and they said, our students just are not ready to understand that what's happening outside is not the same as what's occurring to their body. So they do weather observations, but then they're like, but I'm warm, so it's warm today, because they're inside or they're wearing their coat and boots. So I'm wondering, you know, how can we do this? Graph the days of the month and compare different months. That's a beautiful way to start describing patterns. Nice. Ooh, I love talking about it at recess. They're already engaged in outside play. Good. What about, yeah, you're exactly right. So that's what they do. They think it's sunny, even when it's snowy. If it's sunny outside, they're like, must be hot. I don't need a coat. Look at the sun out there. You're exactly right. So you do talk about temperature. Excellent. What are some investigations we could carry out to support that understanding, to support that transfer of knowledge? And I want to acknowledge that this is very abstract for these little brains. So it's not easy. And it's not something that they're going to understand after just one effort. But what could we do, or what do you do regarding investigations so they can further develop their understanding of weather and patterns? Has anyone tried anything? Maybe not. Maybe this is a place where we can you. Oh, go ahead.
I don't want to comment. I don't want to type it in. Sorry, I'll just say it. But I brought snow in when it was snowy in our town, and I let them feel how cold it was, and then we took spray bottles and painted it.
Ooh, I love that. That's a great idea. Like, and especially when you bring the snow inside, because they think, oh yeah, outside might be cold because there's snow there. But when I come inside, I am warm, so it must be warm. That's a great idea. And a wonderful way to integrate the arts as well. Beautiful. Thermometers in the sun and shade. Very cool. Exactly. Oh, that's such a fun activity. Tasha, that's a great idea. I love it. I would be so excited to make snow cones. I'll tell you, the first year my husband and I were married, we really wanted snow cones, but it was also December where nobody was selling snow cones. So we did just collect a pot of snow and made snow cones for ourselves. So there we were in our early 20s making snow cones out of snow and like, you know, the colored flavored stuff that you would like put in Sprite for drinks. We were so proud of ourselves. It was wonderful. Probably the best snow cone I've ever had. Excellent. Well, I'm going to keep going, and I'm also going to keep in mind these 4 components as we talk about some of these other content areas. So the first category of content in the science standards is weather. Now, the next one is light. And I put some examples up here. What are you seeing in these? What are you thinking about? Why might I have chosen these images?
I immediately thought that slide on the right would be burning hot.
Exactly. So one of the science standards for ages 3 and 4 is to understand that different materials react differently to sunlight. And when I first thought of that, I thought the exact same thing. I said, I need a metal slide. And then I had to get a plastic one for comparison, right? But you're exactly right. Like, which one of these would you want to be on, either in cold or hot temperatures, you know? I'm definitely the plastic one. Good. What else do you think I had in mind when I showed these pictures or when I selected these? This picture is a little, oh yeah, the plants, they need sunlight to grow. Yeah, with the seeds. So this is, now is this something you could replicate? Could you grow in your classroom some sunflower seeds, one set in the light and one set in the dark? Because they will grow, they just look really sickly. they'll do something. This picture, I know this bottom one is kind of hard to understand. This is a blanket fort. And in this particular fort, someone has had the idea to put a lamp shining on it. What do you think we could be learning with that picture? Or why would we want to carry out that type of investigation? Any ideas? Shadows? Oh, that's great. I love the shadow idea, and it's actually not related to shadows, but it could be. I think that would be an excellent addition to these investigations. So the particular standard that I was thinking about when I picked that picture was carrying out an investigation to show the effect of light illuminating objects. And we also get that one here, right? The sun is a big light and it lets us see things. When we can't see the sun, it's dark. Exactly, light and dark. Yep, using flashlights. Have them go through a maze they make with the lights off versus the lights on. Why is it easier? What changed? All it was that little light. And that standard is about the effect light has and how it illuminates things for us. I also thought there's a standard that talks about the effect of different materials. So we talked about that here. And I thought it might be interesting. You mentioned that we sometimes use thermometers in the shade and on sun. Well, what if we put one student a black shirt over their clothes and one a white shirt? What kind of impact would that have? What would we anticipate our students experiencing in that setting? Who would probably feel colder? The student in the white shirt or the student in the black shirt? We're going to have to try it, guys. That's my challenge. Try this one now. So ideally, so we would expect if they were the same weight and things like that, that the person wearing the black shirt would be a little bit warmer because it absorbs the light, whereas the white reflects it. So that might be a fun way to have students start to understand that concept. And again, we aren't expecting 3-year-olds to walk away with this in-depth knowledge about light reflections. Good heavens. I started to say refractions and got excited. But that would be another way to introduce them to the idea that color and material have an impact on our perceived temperature. Any questions about the light content that we've talked about so far? You're good? Okay, we're going to keep going. All right. Now this one, this content is all about the science of living things. And I just pulled some examples from activities that we at the STEM Action Center have liked. Maybe we have modeled some activities after these, but some of the things that we thought would be interesting, and you mentioned this earlier, were habitats. So what do living and non-living, like what's the difference? How can we tell them apart first? Because sometimes that's challenging. But one of the components of the standards on living things talks about the need for young to be cared for by their parents. So I always think it's nice to identify living things often have an infant form versus an adult form. And that's normal. And sometimes they look really similar. And sometimes they look really similar, but are just a little smaller. And sometimes they look really different, like a frog and a tadpole. I wouldn't start with those on a worksheet because they look super different. And I would never think, unless I knew that they went together, that I should draw a line between those two, because it's kind of weird. A lot of insects are that way. Quite a few reptiles are that way, or amphibians. So just something to keep in mind as you're introducing students to that idea. Maybe start a little easier and then you can get more complex. I have a niece that is just turned 3, and she believes that her favorite rock is a living thing. And I'm okay with that, because she also does things like she tries to give it water, and she tries to give it food, and that's adorable. And also they're not being consumed. So it's like, maybe they're not alive, right? Like if they're not using it, it could be telling us that it's not a living thing. So activities and different ways that they can develop their understanding of living and non-living things, and what living things need to stay alive. And that's what this picture here represents. So they do need some sunlight, unless, I don't anticipate you discussing like extremophiles with 3-year-olds, because that would be a lot. So the living things that they are going to be familiar with all need these things. And there are appropriate kind of experiments or investigations where you do give a rock some food. Does it consume it? Yes or no? Well, then is it alive or is it not alive? Now, some things it's a little hard to tell if they're consuming their food, like plants, but that leads to another discussion. Well, then how do we know it's alive? Well, it still needs sunlight, and it needs air, and it needs water. Maybe we just can't see how it's taking in food. So lots of great discussion around living things with some different ideas that you could try. The last science content for the 3 and 4-year-old ages is matter and motion. And those are some kind of big words for 3 and 4-year-olds. So breaking them down, we're talking about things moving, and we're really focusing on pushing and pulling, and pushing would include like knocking things down, which is why I included these kind of dominoes. I know that we recently purchased for a classroom grant for a classroom of preschoolers. We bought a ramp for their cars to go down, so they could practice pushing it down or pulling it up, and talking about which one used more force, which one did they have to work harder for, so they can start to understand the difference between those two ideas. We also have things like liquids and solids and gas. What are they? How are they different? How can they be used? And also, where do we find them? So those are all fantastic. Another fun one for this age group is sink or float. And this is a really introductory idea when it comes to density, but them just being interested in investigating sink or float is really fun. It seems to be really engaging every time I've tried it. They always want to try something that I never would have thought of, and it just leads to them asking more questions. So what we're hoping for are questions like, what would this sound like? So when you are, ooh, I love this, root view. Root view planters are great for showing how plants drink and eat. Thank you for sharing that. I'm going to have to check those out. That's wonderful. I'm going to make a note. Thanks. So some of the questions you could ask your students when you are having these types of experiences: what does it sound like? What does it smell like? What does it look like? I would not go to taste unless it's actually something they can taste. So we want to encourage using the senses safely. We want to encourage them noticing similarities and differences. We also know that this age group is so great already at wondering. So I was thinking about the rain and snow picture, and the question that first came to my mind was, where did the ants go? Like, where are they going during the winter? how did that happen? Another fun thing is we introduce them to, you know, other species that we share our space with on Earth. If you had legs like a frog, if you had a pouch like a kangaroo, those kinds of things, just taking them outside their own body and thinking about what they would do if they had a different shape. Also things like, what happens if we mix these things? And again, we want to be careful with this one, so we're not mixing things that are, that could cause problems. You know, even things like baking soda and vinegar, which are innocuous by themselves, get, you know, they get the bubbles and stuff. So just be aware and keep their messes contained, but try to not kind of stop any of that exploration as best you can while keeping safe. Now we're going to shift to a little activity here. I'm going to skip that for a moment. Ready to go. I want you to look at these 4 shapes, or these 4 objects. And I want you to identify the one that is different. And I want you to have a reason why. I'm going to give you, let's see, maybe 10 more seconds. Make sure you can justify your answer. Good. I see a few answers in the chat. Nice. All right. Very good. Excellent. Well, let's just go through these quickly. So, Jennifer, you said the heart is different. It doesn't have multiple points. This one, so sometimes people say it's this one because it doesn't have any flat lines. And then we had quite a few people say it's the star because it doesn't have a red outline. And then we've got the green one because it has 2 parts. It's a composite shape. It's comprised of 2 smaller shapes together. So we have a triangle and a rectangle. Woo! And some people said that it was this one because it's not filled in. Now, all of your answers are correct. And the reason that I love starting any math discussion with these types of activities is because it demonstrates that you can have your answer and you can justify it based on the facts, and it's still not the only right one. We want to remember when we are teaching our earliest learners about mathematics that oftentimes, and I'm saying often because I don't want to use the word always, because there's always some weird example, right? But oftentimes in mathematics, there is more than one right answer. And if there really is one right answer, there's almost always more than one way to get there. So when we are teaching our young people about math, we want to teach them to come up with multiple solutions. We want to teach them to come up with multiple reasons. We want to encourage them to think about how someone else sees something. All of those are important when it comes to math. I also want to say when it comes to math instruction that a lot of research has been done, and what we're learning is that by the age of 5, a student's self-perception of mathematics is pretty much like instilled in them unless interventions are done to change it. So by the age of 5, if a student feels that they are not a math person, and we should never hear kindergartners saying, I'm not a math person, but we do. We have to ask, what are we as adults doing to make it seem like this isn't an option for this student? So keeping that in mind, I want to go through the content areas associated with mathematics for this age group. So the first one is counting and cardinality. So this is that one-to-one relationship. And as the numbers go along in their pattern, it means an increase in the number of objects. And you can do so many fun activities about this. And I'm going to go through these kind of fast because I want to show you some resources we have. But counting and cardinality is the first one. And this is one that there really isn't. I mean, like they do have to go in that order. So, you know, you guys know what I'm saying. Like sometimes you get the kid that counts and it's like 1, 6, 4, and you're like, that is a great start. And let's just fix some of that ordering because the sequence matters in that instance. We also want them to start telling the difference between the number shapes and the letter shapes. So can we tell the difference between those symbols? Now, next is our operations and algebraic thinking, which is kind of sounds advanced, but that really comes down to really basic addition and subtraction, like up to 5, and then patterns fits into this. And you can do patterns so many ways. You can do them with art, you can do them with music. We already talked about how to do them with weather. So you can find patterns and incorporate the concept of patterns in whatever content you're comfortable with. And look at you also integrating math. What a great STEM teacher, right? That integration is a critical component. The next thing that we want to keep in mind in this operations and algebraic thinking is we're comparing quantities. Does this pile have more or less than this one? And it doesn't need to get more advanced than that. Those are really important foundational skills for mathematics as we go on. Now, we already talked about this activity with operations and algebraic thinking, transitioning to measurement and data. Okay, so I included this picture of the 4 dogs because this is another example of that same activity. Which one is different? Well, they're all actually could be identified as the different one. Same thing here. We're doing some comparisons with measurable attributes. Which one's bigger? Which one's smaller? Which one's taller? Which one's shorter? Those sorts of comparisons are exactly what we're looking for in ages 3 to 4. We also want to classify and sort things. So we could say, these 3 are white dogs, that is a brown dog. These 3 are big dogs, this is a small dog. So those are the kinds of activities you can use these sorts of images and graphics with that are really friendly for young people, but we can use them for multiple purposes. So we can use them for what's different, what's the same. We can put them in different groups, etc. Have them build their own sets. Now, next is geometry. And I'm wondering, did any of you attend the yoga session earlier? I wanted to go to that this morning, but I couldn't.
It was canceled.
Okay. Well, yoga is a great way to incorporate geometry with our littlest learners' bodies. So I thought that was a wonderful coincidence that would be on the program today. I'm a yoga teacher. I do it with little kids, and it's a wonderful way to get them familiar with their bodies and exploring shapes. It's also a wonderful way to develop some spatial relationship awareness. So in front of, behind, next to, over there, under, it's a great way to incorporate. I'm going to keep going because we only have a few minutes left. I've never done this live, so I didn't know how long it'd take. I apologize. Now, I wanted to show you a couple of resources we have. So the STEM Action Center, when the pandemic started, we realized that we needed to come up with some supports that families could do at home. We also know that Utah parents, we gave a survey to people across the state, and what we learned, one of the things we learned was that Utah parents do not feel like they have the skills they need to teach even their earliest learners about mathematics. So we developed a program called To Learn. And these are little kits that we've been making. We have 5 of them right now. The one that you can see a picture of here is called Move to Learn. So we started with the math standards, and then we built in fun activities that a student ages 2 to 4 would already be interested in doing. We also have kits for ages 5 to 8. So this one, like I said, is Move to Learn. This is for 5 to 8-year-olds. I didn't get a picture of the other one, but we have some sidewalk math where we are playing kind of like a hopscotch game or like a board game, only with people. And you have to create your own equations and find the answers. And then that's the square you move to. We have a distance and time game, and then a jump rope game. And we provide all of the materials they need for these activities, as well as directions and instructions for them. And then we also include family extension activities. Now, one thing that I wanted to make sure you had access to were these materials. We're working on getting them on our website, but I was like, I am not going there and telling them that they'll be there soon. So what we've done, I'm going to just escape really quickly so I can copy this. And I'm going to paste it in the chat box. It looks like this. I've also put the presentation in the file that you have access to, so you can access it through the links. I will tell you that Explore to Learn and Play to Learn we're waiting for the printers to give us back our designs, and then we'll pop them in these folders. But like Build to Learn, here are the activity cards for ages 2 to 4, and here they are for ages 5 to 8. We tried to make them similar if possible, so maybe an older sibling could help a younger sibling. But if you click on this, you'll see the 3 activities. And the only thing that we can't give you online, if you don't actually have a kit in front of you, is the materials. So I wanted to tell you about one more thing that we have available to you, and that is our classroom grant. So our classroom grant opens in early August and closes at the end of September every year. You can be awarded up to $1,500 for your grant request. This is a program that I oversee, and I tell this to everyone, and I think 4 people in the entire 6 years have taken me up on it. If you need help writing your grant application, if you don't feel comfortable doing that, please contact me and I will help you. I don't review the grants, so I am fine providing that assistance so we can help you become the teacher you want to be. Now, along with that, every time we have had a preschool applicant, which has been 3 times in 6 years, they get funded. So this isn't something that's out of your league. Preschool is actually an area that we want to support more, so I give them bonus points for applying. Please, please, please take advantage of this. If you want to know more about it, just go to our website here, stem.utah.gov, and then under educators, you'll see a link that says grants, and you'll find the classroom grant. But I'm also going to scroll back up to the first page here, and this is my email address. If you want more information, like I said, if you want help, if there's a team of you and you all want to apply together and would like me to walk you through the application, let's do it. Let's get something set up. I want to support you in that. I just need to know that you want the help, and I'm there for you. So My email address is just my name, kellyyates@utah.gov. I hope I get an influx of emails. Thank you all so much for coming. Please let me know if you have questions, if there's something else we can help you with, if there's a standard that's challenging that you'd like some help or brainstorming with, let us know. We're here for you. And we'd love to serve you however we can. Thank you.